In 2.5, we talk about transformations of functions. So we have a couple of common functions that we need to know what their graphs look like. So the table below gives names to 7 frequently encountered functions in algebra. You'll want to study the shape of each graph and the function's characteristics. Knowing these graphs is essential for analyzing their transformations into more complicated graphs. So the first one we have is the constant function, or this is just the horizontal line, which has a slope of 0. Its domain is from negative infinity to positive infinity. Its range is just that single number c. It's constant on negative infinity to infinity, and this is an even function. We have the identity function, and this is just f of x is equal to x, or y equals x. Its domain is from negative infinity to infinity. Its range is also from negative infinity to infinity. It's increasing the entire way from negative infinity to infinity, and this one is an odd function. The third one is the absolute value function, and this looks like a V. So f of x equals the absolute value of x. The domain is all real numbers. The range is from 0 to infinity, including 0. It's decreasing from negative infinity to 0 and increasing from 0 to infinity, and this is an even function. You've got your quadratic function, which is f of x equals x squared. The domain is all real numbers. The range is from 0 to infinity. It's decreasing from negative infinity to 0 and increasing from 0 to infinity. And this is an even function. The square root function, or f of x equals the square root of x. The domain is from 0 to infinity, and so is its range. It's increasing from 0 to infinity, and this is neither even nor odd. We also have f of x equals x cubed. This is the cubic function. The domain is all real numbers, and so is the range. It's increasing from negative infinity to infinity, and this is an odd function. And the last one is the cube root function, or f of x equals the cube root of x. The domain is from negative infinity to infinity, and so is the range. It's increasing from negative infinity to infinity, and it's an odd function. So these 7 graphs are very important to know because we're going to use these basic shapes to move and transform it into a new graph of a function. So below is a summary of transformations. So for vertical shifts, what you're doing is you're adding or subtracting a number that is not attached to the x. So if it's plus c, that means you're raising the graph by c units, so you're moving up c units. And if it's minus c, that means you're lowering or shifting it down that many units. So the c is outside of the x piece. X is not being manipulated. For a horizontal shift, we have x plus c inside the function. And so if it's plus c, you shift the graph to the left that many units. If we have f of x minus c, you shift the graph to the right c units. Reflection about the x-axis. So this just means that I'm flipping it over the x-axis. So that means I have negative f of x. So just flip it across the x-axis. The other way is the reflection about the y-axis. In this case, I flip it across the y-axis. So So we have f of negative x. Then we have shrinking and stretching. So for vertical stretching or shrinking, it's c times f of x as long as c is greater than 1. So you vertically stretch the graph by c. If it's c times f of x and c is in between 0 and 1, or it's a fraction, you are vertically shrinking the graph of f. And for horizontal stretching or shrinking, if it's f of c of x and c is greater than 1, you're horizontally shrinking the graph. And if it's f of c of x, where c is in between 0 and 1, you're horizontally stretching. So let's go ahead and apply these rules to the first example. So use the graph of f of x equals the absolute value of x to obtain the graphs of g of x, which is equal to the absolute value of x minus 4, and h of x, which is the absolute value of x plus 3. So let's first graph f of x, which is the absolute value of x. And this is the v graph. So you've got a point on 0, 0, you've got 1 on 1, 1, and negative 1, 1, and you just keep going up in a V shape until the graph is completed. So this is our first graph. And so we're going to use this original graph to get my other two graphs of g of x and h of x. So f of x is in black. Let's go ahead and do g of x, which is the absolute value of x minus 4. And I'm going to do this one in red. So g of x equals the absolute value of x minus 4. So that means that I am vertically shifting my whole graph down 4 units. So each point on my f of x graph is now just going to be shifted down 4 units. So let's take the origin first. 1, 2, 3, 4. So I've got, now my origin is down at 0, negative 4. And so you'll do this with every single point. And so our new graph looks something like this. So all we did was we shifted the original graph down 4 units. And this is g of x. Now let's go ahead and do h of x. And so h of x is going to be in purple. That's the absolute value of x plus 3. And so now, because it's a plus, I'm going to move up 3 units. So just use the original graph, and we're going to move it up 3 units. So 1, 2, 3. That's where my new origin is at. And then you'll just complete the rest of the points the same way. And so we have h of x. All right, So now let's try using the square root graph to obtain g of x, which is the square root of x plus 5, and h of x, which is the square root of x minus 4. So my plus and minuses are now with my x piece, which means it's now horizontal shifting instead of vertical shifting. So let's graph the first part of this. So we've got the square root function. And so that starts at the origin and it increases to the right. And if you don't remember what these look like, you can always just pick random x values and connect your points. So f of x looks something like this. Now let's go ahead and do g of x, which is x plus 5, square root of x plus 5. And so because the plus 5 is underneath with the x, that means I'm shifting it to the left or to the right. And since it's plus, we're going to shift it to the left 5 units. And it's almost the opposite of what you want to be. You think you'd want to go more positive because you're adding 5, but you're really going to the left 5 units. And so all we want to do is we're just going to shift all of our points 5 units to the left. So 1, 2, 3, 4, 5. My new origin is at negative 5, 0. I'll have a point at negative 4, 1. And I have a point at negative 1, 2. And so that's g of x. Now we just want to do h of x. So h of x is the square root of x minus 4. So because it's the square root of x minus 4, we'll now be moving to the right 4 units. So you just take the original graph and you move it 4 units to the right. And you can't really see the third point, but you can get the idea. So that's horizontal shifting to the left and to the right. Now let's go ahead and try a cube root function to obtain the negative of cube root of x and the cube root of negative x. So whenever there's negative is involved, that means we're going to be flipping it over the x or the y axis. So let's go ahead and do the original one. We've got the cube root of x. And so this kind of looks like an elongated S. We have a point at 0, 0. We've got a point at 1, 1, and negative 1, negative 1. We have a point that's like at 8, 2, so somewhere around there, and negative 8, negative 2. So just to get an idea, that's f of x. Now let's look at g of x and h of x. So g of x is the negative cube root of x. So the negative on the outside means that you're going to flip it over the y-axis. I'm sorry, the x-axis. because the negative is on the outside. So go ahead and flip this over the x-axis. So I had the point 1, negative 1, which now means I have the point 1, negative 1. 0, 0 will stay right where it's at. And negative 1 now becomes negative 1, 1. Same idea goes for my 8. I have had 8, 2 to begin with, and now I have 8, negative 2. And negative 8, negative 2 now becomes negative 8, positive 2. So that's g of x. And let's go ahead and do h of x. So h of x, which is the cube root of negative x, we flip this over the y-axis. And so starting with my original graph, 0, 0 will still stay in the same spot. 1, 1 is now going to become negative 1, 1. And negative 1 is now going to become 1, negative 1. And the same idea goes for my 8, 2. Now becomes 8, negative 2. And negative 2 becomes negative 8, positive 2. And so what ends up happening is we actually get the same graph. All right, now let's go ahead and try stretching and shrinking. So we're going to use the absolute value graph to obtain g of x, which is 2 times the absolute value of x, and h of x, which is 1/2 times the absolute value of x. So let's go ahead and plot the original graph. This is the v function again. You start at 0, 0, and then you just move up in both directions, making a V. All right, so now let's look at g of x, which is 2 times x. 2 times the absolute value of x. So because the 2 is being multiplied outside and it's greater than 1, you are vertically stretching the graph. And so in order to do that, you multiply each of the y coordinates by c, which in this case is 2. So for example, let's take the point 1, 1. So your x stays the same, but you multiply your y coordinate by 2. And so my new coordinate will now be 1, 2. 0, 0 is not going to change. Negative 1 is now going to go up to negative 1, 2. At 2, 2, we're now going to have 2, 4. And same thing with negative 2. At 3, you're going to have 6. And so you can see that the graph is now being stretched vertically, which makes it more narrow. So that's g of x. Now let's go ahead and do h of x, which is 1/2 times the absolute value of x. And so now, because it's in between 0 and 1, you are vertically shrinking the graph. And so you're going to multiply the y coordinate by 1/2. So the point 1, 1 is now going to become 1, 1/2 times 1. But this is just 1, 1/2. Still going to have 0, 0. So instead of having 2, 2, we're now going to have 2, 1. Instead of having 4, 4, now we're going to have 4, 2. And so we can go ahead and connect the points. And so when I vertically shrunk the graph, you can see it's now become wider. Than vertically stretching. So let's talk about the order of transformations. What if I have more than one thing going on with my graph? That is completely okay, and it's pretty normal. So what we want to do is you're going to take horizontal shifting first. Then you'll do stretching or shrinking, whether it's vertical or horizontal. Then you'll reflect it, whether it's over the x-axis or the y-axis, and then you will vertically shift it. So use the graph of f of x equals x squared, and we're going to graph g of x, which is 2 times x plus 3 squared minus 1. So let's go ahead and graph the original first. This is the quadratic, which is a parabola. So we got something along these lines. Okay, so now let's talk about g of x. And now we have to put these in the right order of things to move or transform my graph. So g of x equals 2 times x plus 3 squared minus 1. Okay, so first is horizontal shifting. So the horizontal shifting is the plus or minus that goes with the x. So in this case, we want to shift it to the left 3 units. The next thing is stretching or shrinking. So because we have 2 times x plus 3, that means we are going to stretch the graph by 2 units. Next is reflection. So this is when we have a negative on the x or on the entire equation, which in this case, there is none. And the last thing is vertical shifting. And in this one, we're going to move down 1 unit. So in order to do this, you want to take 1 point at a time and do the 4 movements to that 1 point. Then do it to the rest of the points. So let's take the origin first. So from 0, 0, we first want to move 3 units to the left. So 1, 2, 3 units. Then you're going to stretch the graph by 2 units. So we're going to multiply our y-coordinate by 2. But because our y-coordinate is 0, it's not going to move. We're not reflecting it at all. And then we want to shift it down 1 unit. So our new origin is at the point -3, -1. Now let's go ahead and do this with 1, 1. So move 3 units to the left. You're going to multiply your y-coordinate by 2. So it's now going to be 2. We're not reflecting it. And then we need to move down 1 unit. Let's do the same thing with -1, 1. So we're going to move it 3 units to the left. You want to stretch it by 2, so multiply by 2. So now we're going to move back up to 2. And then we're going to shift it down 1 unit. Let's do this with 2, 4. So move it to the left 3 units. Now you're going to multiply by 2. So 4 is now going to become 8, which is off of my graph. It'll be somewhere up here. And then you shift it down 1 unit. And the same thing for -2, 4. Move it to the left 3 units. You're going to multiply by 2 to get to 8, and then shift it down 1 unit. And so my new graph is now moved to the left, and it's skinnier than the original graph. All right, let's do one more. So we're going to use the absolute value graph so that we can find g of x. So let's go ahead and plot the absolute value graph, which is the v graph. All right, so g of x is negative absolute value of x plus 4 plus 1. So first is horizontal shifting. So we have x plus 4, which means I'm going to move it to the left 4 units. Then becomes stretching and shrinking. So we don't have a number that is manipulating the x or the entire thing. So there is no stretching or shrinking going on. Then is reflection. So because the negative is on the outside of the whole function, it's about the x-axis. And then vertical shifting. We're going to move up 1 unit. So let's go ahead and start with the origin. So we're going to move to the left 4 units. We don't need to stretch or shrink, and we can't really reflect if we're on the x-axis. So the only thing left to do is to move it up 1 unit. So my new origin is at negative 4, 1. Let's go ahead and do this with 1, 1. So move it to the left 4 units. We're not stretching or shrinking, but we will reflect it over the x-axis. So because I'm now at negative 3, 1, I'm going to do negative 3, negative 1. And then you move it up 1 unit. So I ended up on the x-axis anyway. Let's do this with negative 1, 1. So we're going to move it to the left 4 units. We're going to reflect it over the x-axis, and then we're going to move it up 1 unit. And so once you get the idea of these shapes, you'll see that where the rest of them need to fall. And so my transformed graph looks something like this.